Hi everyone, we are going to start Cambridge IGCSE investigation paper for section October-November 2025. The subject is International Mathematics with the code 0607. This is the paper 5 and the variant is 3. Let's move to the investigation section, which is odd set. In this investigation, you will look at calculation made from the odd number of connected integers. Using these steps, the step 1 is write down an odd number of integers that increase by the same positive integer each time. Step 2, multiply the first and last integer, and step 3, square the middle integer. Example, this is the set of 3 integers that increase by 1 each time. 3, 4, 5, and each one increase by 1. And step 2, we need to multiply first and last integer, which is 3 and 5. So when we multiply 3 with 5, we get 15. Step 3, which is the square of the middle integer, which is 4. So 4 square is 16. Okay, complete this table. We have the three integers 1, 2, 3, and these are integer which increase by 1. So when we multiply 1 by 3, we get 3. This is the step 2. Similarly, the square of the middle one means square of 2, so this one should be 4. Now, set of second integers in which 5, 6, 7. These integers are increased by 1, and we need to multiply first and last integer in step 2. So 5 times 7 is 35. In step 3, we will square the middle integer, which is 6. So 6 square is 36. Similarly, when we have the three integers increased by 1, in this case 8, 9, 10. So the first and last integer should be multiplied. So 8 times 10 is 80. So 8 times 10 is 80. And the square of the middle one, which is 9 square, is 81. In this case 14, 15, 16 increase by 1. So in step 2, we will multiply first and last integer, which is 14 times 16. It is 224. And in step 3, we will take the middle integer and square it. So 15 squared is 225. Now write down the connection between the answer of step 2 and the answer of step 3. This is the answer of step 2 and this is the answer of step 3. You can see that there is a pattern. For example, 3, then 4, 35, then 36, 80, 81, 224, 225. So answer to step 2 is 1 less than the answer to step 3. Part C, in the set of 3 integers that increase by 1 each time, one of the integer in the calculation for step 2 is 23. The answer in step 3 is 482. In step 3, we take the middle integer and square it. So middle integer, I am representing mi, middle integer is equals to the square root of the answer to step 3, which is 484. So square root of 482 is 22. And it is given that one of the integer in step 2 is 23. So it's mean the middle one is 22. So the last one will be 23. So we can say that 22 and 23. So first one will be, as there is an increment of 1, so first one will be 21. So we can write 21, 22 and 23. Question number 2. In this question, a set of 3 integers increase by 2 each time. Complete this set by 3 integers. There is an increment of 2. So when we add 2 to the 7, we will get 9. And when we add 2 to the 9, we get 11. Okay. Work out the answer to step 2 and step 3. In step 2, we multiply the first and last integers, which is 7 times 11, and in this one is equal to 77. So step 2 is 77. And in step 3, we take the square of the middle term. So 9 square is equals to 81. make up three more set of three integers that increase by 2 each time. Investigate the connection between the answer to step 2 and in step 3 write down this connection. For example, we take 5. If we increase by 2, so it will be 7, then 9. Okay. And in this case, if we apply step 2, I am representing S2. So we need to multiply first and last integer. So 5 times 9, which is equals to 45. Okay. And when we apply step 3, which is the square of the middle term, so in this case 7 is the middle term, so its square is 49. Okay. Now we take 11, then increase by 2, so 13, and then 15. Now in this set of the integers, we apply the step 2, which says that the multiply the first and last integer. So in this case 11 times 15 is equals to the 165. And when we apply step 3, which says that the square of the middle integer, which is 13 square, and this one is equals to 169. Similarly, we take number 20, then 22, then 24, which has the difference of 2. You can see increment of 2. So now apply again the step 2, which says that the multiplication of first and last integer, so 20 times 24 is equals to the 480. Similarly, when we apply step 3, which says that the square of the middle term, so it's mean 22 square is equals to 484. Now we need to write the answers of the step 2 and step 3 in column wise so that we can find the connection. For example, step 2 and this one is step 3. In first case, S2 was 45 and answer of the step 3 was 49. Similarly, in second case, answer of the step 2 was 165 and answer to the step 3 was 169. Similarly, in third case, answer to the step 2 was 480 and answer to the step 3 is 484. So can you find any connection or any pattern? When we increase 4 to the answer of step 4, we get the answer of step 3. For example, 45 plus 4, we get 49. When we add 4 to the 165, we get 169. When we add 4 to the 480, we get 480. We can say that the answer to step 3 is 4 greater than answer to step 2. Okay. Now let's move to the question number 3. In this question, a set of 3 positive integer increase by 3 each time. Now there is an increment of 3. Complete the table. 1, 4, 5. You can see that 4 minus 1, we get 3. 7 minus 4, we get 3. So there is an increment of 3. And in step 2, we multiply the first and last integers. So 1 times 7 is 7. And in step 3, we take the square of the middle term. So 4 square is 16. Similarly, we have another set of the numbers which is 3, 6, 9. Difference of the 3 or increment of the 3, you should remember. In step 2, we multiply first and last integer, which is 3 times 9, and this one is equal to 27. And in step 3, we take the square of the middle term, so this one is 6 square. Similarly, 10, 13, and 16. And in step 2, we multiply first and the last integer, so this one is first term is 10 and the last term is 16. So 10 times 16 is 160. Similarly, we take the square of the middle term in step 3, so the 13 square is 169. Now we need to find the set of the numbers, and we know that the step 3, which is the square of the middle term, so answer to the step 3 is given, which is 324, and we take the square of 324. So first we take the square root, and this one is 18. So we can say that middle one is 18, and when we increase 18 by 3, so it will be 21, and if we decrease 18 by 3, so it will be 15. So we can get the number set of the numbers by just increasing the 3 or decreasing the 3 if we have the middle number. Now if we multiply 15 times 21, we will have 315. You should double check it. Write down the connection between answer to step 2 and the answer to step 3. You can see that answer to step 2 is this one and answer to the step 3 are these one. So we need to find some pattern between step 2 and step 3, or answer to the step 2 and answer to the step 3. So 7 then 16, 27 then 36. I think there is a difference of 9, and in this case 36 minus 7 is also 9. So 160 and 169, yes, and the connection is that the answer to the step 2 is 9 less than the answer to the step 3. Question number 4. Complete this table for set of 3 connected integers. Use your answer to the question number 1b, question number 2b, question number 3b, and any pattern you notice to help you. Increase between integer each time is 1. It means if there is an increment between number is 1 in the set of numbers, so answer to the step 3 minus answer to the step 2 is, in first case we study that difference of the answer to the step 2 and step 3 is 1, means answer to the step 3 minus answer to the step 2 is 1. 4 minus 3 is 1, 36 minus 35 is 1, 81 minus 80 is 1. So we can say that when there is an increment of 1, the answer is 1. Now when the increment is 2, means we need to go for question number 2b, and we observe that when we have the increment of 2, the answer to the step 3 is 4 greater than the answer to the step 2. So we can say that there is a difference of 4. Now increase between integer each time is 3. So we just solve the question number 3b, and we observe that the answer to the step 2 is 9 less than the answer to the step 3. So there is a difference of 9. Now you can observe the some pattern that when we have the increment 1, the difference of the answer in step 3 and step 2 is 1. When the increment is 2, is difference of the answer is 4. When we have the increment 3, difference of the answer is 9. So you can see that 1 square 2, so square of the 2 is 4, then 3 increment is 3, so square of the 3 is 9. So when we have the increment 4, the square of the 4 is 16. When we have the 5, so square of the 5 is 25, and when we have the k, so square of the k is k square. Now question number 5. For the set of 3 connected integers, the answer to the step 3 minus answer to the step 2 is 225. 225. We just observed that when there is an increment of k and the difference of the answer to the step 3 and answer to the step 2 is equals to the k square. So in this case, this one is the k square. So increment will be k, which is equals to the under root of 225, and this one is equals to the 15. So it's mean these connected integers will have the increment of 15. The integer can be positive and negative. It means we can have negative values or positive values both. The integer increased by same positive integer key. Answer to step 2 is negative 125. So let's suppose we have the three integers a, then a plus k, because increment of these connected integer is 15. So a plus k, then a plus 2k, and in this case k is equals to 15. We just calculated, so this one is a comma a plus 15, then a plus 2 times 15, which is 30. So this one is 30. Now it is given that step 2 is 125, and we know that in step 2 we multiply first and last integer. So first and last integer are a times a plus 30, and the answer to the step 2 given, which is negative 125. Okay, now we can solve this one. A times a is a square, and a times 30 is 30a. And when we switch negative 125 on the left side, it will be positive 125 equal to 0. So this is a quadratic equation and can be solved by factorization. For example, 125 times 1 is equal to 125, and 25 times 5 is equal to 125. And when we add these two numbers, 25 plus 5, we get 30. So this quadratic equation can be written as x square plus 25a plus 5a plus 125 equal to 0. When we take a common, we get a plus 25 plus 5 common, we get a plus 25 equal to 0. So we have a plus 5 times a plus 25 equal to 0. These are two factors equating each with 0. We will have a plus 5 equal to 0, and on the other case a plus 25 equal to 0. So a in this case is negative 5, and in second case, in other case, we have a is equal to negative 25. So set of integers are a, then a plus 15, then a plus 30. Okay. Now, when a is equal to negative 5, then this one will be negative 5. Then negative 5 plus 15 is 10. Then negative 5 plus 30 is 25. So this set is negative 5, then 10, then 25. Another set, when we use the value of a equals to negative 25, so a is equal to negative 25, then a is negative 25. Then a plus 25 means negative 25 plus 15 is 10, negative 10. And then a plus 30 means negative 25 plus 30, which is 5. So this one is negative 25, negative 10, then 5. Before moving to next question, you should confirm that the step 2 has the answer of negative 125. So negative 5 times 25, this one is the step 2. So it confirms that it is 125, negative 125. Similarly, when we multiply negative 25 times 5, which is step 2, so this one is also negative 125. So this condition satisfied, so we can confirm that our answer right. Now question number 6, the first of the set of three integers is 10. Okay, this one 10. The integer increased by k each time, this one. Okay, 10 plus k, and then k, 10 plus 2k. Okay, expression of the integers are this. Complete this working to show that your expression in the last cell in question number 4 is true. First we take the square of the middle term, which is the step 3. So 10 plus k whole square, and this one is equal to 100 plus 20k plus k square. Now step 2, which is multiplication of first and the last integer. So 10 times 10 is 100 plus 10 times 2k is 20k. And we know that we use the difference of the answer to the step 2 and step 3, means answer to the step 3 minus answer to the step 2. So step 3 minus step 2, and this one is equals to, so answer to the step 3 we just calculated, which is 100 plus 20k plus k square minus answer to the step 2, which is 100 plus 20k. So further solving, we will have 100 plus 20k plus 12k square minus 100 minus 20k. And positive and negative 20k will be cancelled out, and negative 100 and positive 100 will be cancelled out, and we will have k square. Difference of the answer to step 3 and step 2 was k square. So in this case, it confirms. Now there are now 5 integers in the set. The first integer is still 10. The integer increased by k each time. Okay, write an expression for the last integer in the set. Give your answer in its simplest form. When we have the 10, when we increase 10 by k, so it will be 10 plus k. When we increase this value by k, so it will be 10 plus 2k. When we increase this value by k, so it will be 10 plus 3k. When we increase this fourth value by k, so it will be 10 plus 4k. Show that the expression answer to step 3 minus step 2 is now 4k square. Okay, we know that step 3 is equals to the square of the middle term, and middle term in this case is 10 plus 2k. So its square is equals to the 100 plus 10 times 2k means 20. 20 times 2 is 40k plus 2k square means 4k square. Now step 2, which says that the multiplication of first and last term, so first term is 10 and last term is 10 plus 4k. When we multiply, we get 10 times 10 is 100 and 10 times 4k is plus 40k. Now we need to find the difference of step 3 and step 2. So step 3 minus step 2, which is equals to the step 3, which is 100 plus 40k plus 10 4k square minus answer to the step 2, which is 100 plus 40k. Further solving, we will have 100 plus 40k plus 4k square minus 100 minus 40k. 40k positive and negative will be cancelled out. Negative 100 positive 100 will be cancelled out, and we will have 4k square. So this confirms that the difference of the step 3 and step 2 is 4k square. Okay. Show that the expression in part B is true for this set of the 5 integers. First apply the step 3, which is the square of the middle terms. It means 14 square, and the 14 square is equals to the 196. Similarly, step 2 is equals to the multiplication of first and last term, and in this case is 6 times 22 is equals to the 132. Now, in the given set of the number, the difference is 4. For example, 6 plus 4, 10, 10 plus 4, 14, 14 plus 4. So we can say that difference is 4 means k is 4. And we need to show that difference of the answer to step 3 minus step 2 is 4k. And in this case 4k. So difference of step 3 minus step 2 is equals to 4k square. Step 3 is 196 minus answer to the step 2, which is 132, and equals to the 4 times k square means 4 square. So when we subtract 132 from the 196, it is 64. So 4 times 4 times 4 is 64. So it confirms that left hand side is equal to right hand side, and expression in part B, which is this one, is true. So expression in part B is true. Part D. The integer at one end of the set is 41. There are 5 integers. The answer to the step 3 minus answer to the step 2 is 144. Find both possible set of the integers. It is given that we have the 5 set of the integers. So it may be a, then a plus k. K is the increment, so a plus 2k, then a plus 3k, then a plus 4k. It is given that the one end is 41. Either it may be 41 or maybe this one will be 41. It is given that the answer to the step 3 minus answer to the step 2 is 144. It means answer to step 3 minus answer to the step 2 is always 4k square when we have the 5 set of the numbers. So in this case, 4k square will be equals to the 144. We know that k is the increment, so we need to find the value of k. So k square is equals to 144 over 4, and this one is equals to the 36. So k is equals to 6. Now, if we take the 1 and 41, so first integer is 41. So when we take one, first one is 41. So when we increase it by 6, so 41 plus 6 is 47. Then we increase 47 by 6, so it will be 53. Then we increase 6 for 53 by 6, so it will be 59. Then we increase 59 by 6, it will be 65. So these are the one set. Now, in second set, we consider that 41 is the AND value or the AND integer in the set. So if we take this one 41, now in this case we will decrease the key to move towards left side. So when we decrease 41 by 6, so it will be 36, and we decrease 36 by 6, so it will be 30. Then we decrease 30 by 6, so it will be 24. When decrease 24 by 6, so it will be 18. So 1 2 3 4 5. So this is the another possible set of integers. So we can write it 41, then 47, then 53, then 59, then 65, and 18, then 24, then 30, then 36, and then 41. I hope you learned something from my lectures. Thank you very much for watching my videos, and please subscribe and share with your friends.